All right, welcome everybody. Glad you're here. I know it's a snowy day and sometimes it can be tricky to drive on icy roads, so it's good that you're here. Never put yourself in danger, but driving on snow isn't so bad if you take it slow usually. Anybody here live in Charleston and dealing with the I-64 closure thing? So what route do you have to take to get here?
I go to Nitro, Coca.
Okay, so you go on Route 60? I looked at the...
Back on I-64 at the...
how much extra time did it take you?
Like an hour.
Ooh, an extra hour, that's brutal. Well, hopefully I'll get it sorted out quick. The homework assignment is due on Monday, and I've talked to some of you. It sounds like you've made good progress on that. I got the comment that the assignment seems a little repetitive, just lots of practice using Excel. You'll get pretty quick with the program, and hopefully it'll make good sense to you. Today what we're going to do is look at some complex cash flow diagrams and return back to the paper and pencil method using factor tables. We'll kind of do it in parallel. We'll solve some problems the old-fashioned way with pencil and paper, and get progressively stronger at doing them in Excel also. You maybe remember that in a previous class we took a look at the rate function. And the rate function allows you to identify what interest rate brings equilibrium between an outflow at the present and an inflow over time. That's the most common sequence of cash flow diagrams, is that you'd spend a certain amount now to finance a project, and then that would bring you additional revenue or cost savings in the future. So in the rate function, you can put in the number of periods that the payments will continue, the payment amount, and then some present value. What it's looking for, though, as a note, is it's looking for opposite signs in that function. Because remember, Excel distinguishes pretty clearly between an outflow and an inflow. And so, for instance, you'd want to have a negative amount in the present value if you had paid a certain amount at the present to purchase equipment or begin a new business opportunity. And you need to make sure that the payment value that was a recurring, continual, the same amount with no interruptions, that would be positive in order to get the rate function to work correctly. You can also do a rate function where there's a future value rather than a single present value. And I just want to refresh your memory that, of course, in the case of a future value function, the future value is in the same year as the last annual series payment. So we've, in a previous slide, showed that the typical assumption and kind of our convention as far as find F given A is that the F is in the same year as the A. And so even when we're finding the rate rather than the F or the A, if both the amounts are known and you're trying to find what rate brings it into equilibrium, the same thing holds true, that the F is in the final year of the cash flow diagram. So any questions about that rate function? I'm going to, yes, go ahead.
Should there be 2 commas up in the second one?
Okay, great question.
No.
Yeah, why is there the 2 commas there?
Well, I know there's another term, but on the first one there's not. There's just one.
What you're remembering is that when we do the PV and the FV function, that we need to put in the double comma. But in this case, you don't need the double comma for the rate function. And let's just start up the rate function, because it'll give us those reminders and hints of what it's expecting to see. So when we do equals rate, the first thing it wants is NPER, which is the number of periods. So let's say what if we had 8 periods and the present, okay, now so the next thing it wants to know is the payment. So what if you get $10,000 a year for 8 years, and then you pay, so now it's the PV. So usually what we're doing is we're putting in the double comma to skip over the payment field, but in this case we actually know the recurring payment amount. So just to complete the illustration, what if we had an initial payment of $50,000? So we paid $50,000 and we get 8 annual payments of $10,000. So what interest rate would you need to be in order to bring that into equilibrium? 12% interest. So I'm glad that you are on the lookout, but in this case, no, we don't need to have that extra comma. All right, I'm going to send you an email after class that has a video link. The video is only 7 minutes long, so I think it's really important that you watch the video. The purpose of the video is to show you how to submit stuff with Excel. Hand calculations, it's obvious. You write down on the paper what you did, like little comments and the answer, and you're showing your calculations, and then you take the picture and turn that into a PDF. It's less obvious sometimes what I need to see and what the grader needs to have available in order to give you credit for your efforts in Microsoft Excel. So the purpose of this 7-minute video is to give you an idea of what sort of notes you should put into your Excel file when you're using Excel to solve problems. So if you watch this, it's just a couple of key hints on the things you need to put in there to make sure you get maximum points on your homework problems with Excel. So will you watch that over the weekend?
Yeah, I was confused on what, when you said notes, I realized it was all in Excel. It was
yeah.
I didn't know exactly what notes.
Yeah, the problem is that when you have an Excel function, like let me open up a pretty complicated spreadsheet. I've got some doozies in here. I wonder if this is a good one. All right, so let's say that you're just looking at this. You don't know what equations were used. You don't know what formulas are behind the numbers. And so you need to put in, like underneath here, little explanations about, what is it, where did these interest rates come from? What formula did you use for the payment column? What approach did you use to calculate the total amount paid? And so the purpose of this video will clarify kind of how you leave those signposts behind and how you'd annotate a spreadsheet file to make it more obvious for the grader. And also to remind your own self how to do it if you have to repeat the calculations sometime in the future.
If we didn't do that on the past network, are we going to lose?
Well, I guess what I'll say is the expectations are going higher the more experience you've got.
Okay.
Yeah. And you're just now seeing this video, so. All right. So watch that video. All right, let's look at this cash flow diagram. What we have is an annual series, another annual series, and then a gradient on top of the annual series. And what we want to know is what's the present equivalent of this cash flow diagram. So if we were going to do this one using factor tables, I'm going to step you through in the next couple of slides a procedure that you could follow to find what is P given these amounts in the future. Now the brute force way of doing it is just find P given F for each one of these years individually. But that's kind of an inelegant solution to just repeat find P given F over and over and over for every year. So here's the approach that I suggest that you would take. First of all, as step one, this is an A, so we would want to find P given A. And what that does is it takes the amount in year 9, 10, and 11, and it moves it to a single combined amount in year 8. So we would do find P given A for whatever interest rate applies, and N equals 8. That's the factor that we would look up. And so now there's just one amount at year 8. The next step is that we would take this single amount and we'd move it 8 years to times 0. So that's now find P given F at whatever interest rate applies for N equals 8 years. And now it's moved through time. We've discounted it. You notice that the arrow is shorter? Why do you suppose that graphically I've chosen to illustrate that change in time with a smaller arrow at time 0?
It's worth, less money is worth more in the past, I guess.
I don't know if that's the most efficient way to describe it. I think you're on the right path. How'd you put it?
Been compounded through like the interest and everything over the years.
So it's the opposite of compounding. You said it hasn't been compounded. So when money moves forward in time, the amount grows. When money moves backward in time, we call that discounting rather than compounding. And so this is the effect of discounting. A single amount in the future moving backwards through time is worth less. So it's smaller because the amount was discounted. Okay, so now that annual series that was in years 9, 10, and 11, now we found the present equivalent in terms of time 0. Back when we did this one, when we took it from here to here, we treated year 8 as if it was year 0. It was kind of like a quasi-0. It's like a temporary realignment of what we consider time. We're saying here's the annual series. 1 year before the first amount is our time 0. And so now, just from the perspective of this annual series, when we moved it to a single amount in year 8, we did find P given A. It wasn't really P. We know it was still some future date. It was year 8. But just temporarily, from the perspective of the annual series, we treated it as a quasi-present amount. Okay, so now consider what steps do we have to take to get these amounts down in the outflows. Well, what I suggest is first take the annual series amount of 500 each year to a single amount in year 3. So that's find P given A at whatever interest rate applies, and there's 1, 2, 3, 4 of the $500 outflows. And that's this part of it, but then there's also the gradient, which would move to time to year 3. So find P given G. And we're just temporarily calling year 3 the present. We're just looking at it as that's the present from the perspective of this annual series and also the gradient. So that was the gradient part, this little arrow. And then once it's a combined amount in year 3, we take it to year 0 by discounting at find P given F for 3 years. And then finally we'd combine all of the amounts that are in year 0 and find out are the inflows or the outflows greater. So it's this approach I'm going to ask you to follow in this in-class exercise. So for this part 1, you're not using Excel. You're going to do it with the factor tables that are on the page. Once you finish that, on the back side there is an Excel problem. So this cash flow diagram is similar to the one you just saw. What I suggest you do is kind of outline your procedure. Don't just start writing down the numbers and jump right into your calculator, but in programming there's something called pseudocode, where you kind of put an outline of your strategy. And let me on the whiteboard show you what I mean by like a pseudocode or a strategy. What you could do is you could list the steps you're going to follow and then write it on the board, or not on the board, on your paper like this. Step 1, P/A, I equals 8%, N equals 3, equals, you look up the number, and then that takes the 11,000 from 2 through 4 into a single amount at year 1. So the idea is that if you kind of, at the top of the page, think through what steps you're going to do before you actually run the numbers on it, then you'll probably be less likely to make mistakes. It'll help you to separate the conceptual problem solving with the numerical problem solving. So we're trying to find out what is P, the present amount of all of this stuff. Similar to what I illustrated earlier with the slide step by step. Let me just give you a peek at what maybe your format could look like. It doesn't have to look like this. This is just an illustration of one approach. But for instance, what I'm doing is I'm labeling these arrows, A and B. And then over here on the side where I'm summarizing the steps, I'm kind of calculating the amount. And then with the labeled arrow, I can see what year the amount is in. Because sometimes it's pretty easy to make a mistake and add together numbers that aren't in the same year. And so the reason of putting a label like A, B, C, and D so forth is just to keep track of the timing of what year the amount is in. It's important to keep track of not only the amount, but also the timing of the amount. So this 26,247, that's a positive amount. So it's remember, the arrow up means an inflow, and it's at time 0. So then these other steps,
That value is 1. That's not right. There we go. Right, keystrokes always help. The percentage here tells us
What's your first number? Like, interest rate negative about that. Okay, see?
Okay, so remember that when we're finding future values, we need to add a secondary time column. And that's because the NPER, the number of periods, is not going to be whatever year you're on. For instance, if we're taking this 3,500 from 0 to year 16, that doesn't mean it needs to move 0 years. It needs to move 16 years. So the purpose of this time column is that when we do the FB function and we've already put in the rate and now we're making reference to the number of periods, it needs the correct number of periods to get into the future. So you should get 61,157. Now the problem asks, what if you changed the interest rate around? What interest rate would make the sum of the future values equal to 100,000? So let's create a copy. If you just right click on the tab, the bottom tab there, right click, move or copy. So we'll create a copy and we'll call it change I. So now what I'm going to do here is I'm going to play around with different I values to find out, would a higher interest rate get me closer to 100,000? So that's 10%, 11%, 12%. Rather than keep doing it manually, we can iterate. Date, home, oh wait, no, the data tab, what if analysis, goal seek, and our goal is for this total to be 100,000 by changing the interest rate. We click OK and it'll just iterate around, and it turns out to be 17.2% is what will make the future value equal to 100,000. And then the last question, problem 3 on the in-class exercise, asks, what is the interest rate for this cash flow diagram that brings the inflow and the outflow into equilibrium? So as a reminder how we can use the rate function, here's our cash flow. So if we just type in equals rate, it needs to know the number of years. So there's 7 years. The payment amount is $7,500. The present value amount is negative $45,460, and then it'll solve for what interest rate brings balance between the inflows and the outflows. All right, it's 12:50. We are out of time. Let me remind you that your homework assignment is due on Monday. So if you have questions as you're working on that, I'll do my best to respond if you want to send me a message or stop by my office. But please be sure and watch that video. I'm going to email you the link. Watch that video so that your spreadsheet can include all of the annotation and notes that are required for the grader to understand your solution. Have a good weekend.